Hello math students, today's video is lesson 4.4, rewriting rational expressions. As the title says, in this lesson we are going to rewrite rational expressions. The first thing that we're going to talk about is the difference between a proper and an improper fraction. So if you recall, if I have a fraction that is proper, and we're talking about rational numbers here and not rational expressions, that means that the numerator, remember that's the top, is less than the denominator. If I have an improper fraction, that means that the numerator is greater than or equal to the denominator. So for example, proper would be something like 1/3. The top is less than the bottom. Improper could be something like 5/4. It could be something like 2/2. Those are all examples of improper. Rational expressions are similar, except for instead of comparing the numeric value, so the number on the numerator and the denominator, we are going to compare the degree. Therefore, a rational expression is proper if the degree of the numerator is less than the degree of the denominator, and improper otherwise. Or I can say, in other words, an improper rational expression can be written as a of x over b of x, where a and b are polynomials and the degree of a of x is greater than or equal to the degree of b of x. So remember, the degree is the biggest exponent of the polynomial. So when we're looking at improper versus proper rational expressions, we're looking at what is the biggest exponent on top, so when something's in factored form, and comparing it to the biggest exponent on bottom when it's in factored form. So I want to label each of these as proper or improper. For the first one on here, we're going to look at the degree of the top and compare it to the degree of the bottom. Well, on top, my biggest exponent is on 1. On bottom, so this is in factored form, so I'm not going to just look for the biggest exponent. I want to know if I multiply it all out, what would my biggest exponent be? Well, I have two x's that are multiplied together, so it's going to be degree 2. The top is smaller than the bottom, so I would say this one right here is proper. For the second one, the degree of the top is a 3. On bottom is a 2. So the top is bigger than the bottom, so I'm going to say this is improper. For the third one, the degree of the top is a 2. On bottom is a 4. So it's proper. The degree of the top is a 1. Degree of the bottom is a 1. They're the same. If they're the same, that means that it is improper. And then for this last one, the degree of the top is a 3. Degree of the bottom is a 1. So the degree on top is bigger than the degree on bottom, so it's going to be improper. Improper fractions can be written in a form called a mixed number. So The definition of a mixed number says that if A is greater than B, then the fraction of A over B can be written as A over B equals Q plus R over B, where Q is the quotient, R is the remainder. But we don't usually write a mixed number without plus. Usually we would see it as Q and R B's, or Q, R over B. But there really is a plus that's in between them. So I'm going to take these next three problems, we're going to rewrite them in the equivalent mixed number. So if I take 35 divided by 5, 35 divided by 5 is 7. There's a remainder of 0, so I can just say my answer is 7. If I take 37 and divide it by 5, we can either go and plug it in a calculator or just quickly do some long division. 35, or 5 goes into 37 7 times. I have a remainder of 2. So my answer for this would be 7 and 2/5. And then for number 5, if I divide these, well, 12 goes into 24 2 times. 2 times 12 is 24. Subtract gives me a 0. Bring down the 7. 12 doesn't go into 7, so this is going to be a 0. 0 times 12 is 0. Subtract gives me a 7. So this is going to be 20 and 7 over 12. And that's my mixed number. So the way that we got the mixed number is I divided the two numbers and then looked at my remainder. In 4.3, we talked about how I can divide two polynomials and then rewrite the polynomial in that mixed number form. So that's pretty much what we're doing in 4.4. So it says determine if each rational expression is proper or improper. If it's improper, use synthetic division to rewrite the rational expression such that A of x over B of x equals Q of x plus R of x over B of x. So it's really the same thing as 4.3. Number 6, I have the degree on the top of this fraction is a 2. Degree on bottom is a 1. So I would say this one is proper. And then I am going to, sorry, not proper, improper. And then I'm going to divide. So I haven't changed the sign, so it's positive 2, make it a negative 2. Write down my coefficients. Bring down the 1. Negative 2 times 1 is negative 2. 5 minus 2 is 3. Negative 2 times 3 is negative 6. 6 plus negative 6 is 0. So my original polynomial, so the top, was degree 2. So my answer is going to be degree 1, x to the 1 plus 3. My remainder is 0. So I could say plus 0 over x plus 2, but that doesn't really change anything at all, so I can just write my answer as x plus 3. On number 7, I'm going to look at the degree of the top. The degree of the top is 1. Degree of the bottom is 3. This one is proper, so I'm done. There's nothing else that I can do on here. I could technically say that it's 0 plus 3x minus 4 over x cubed minus 1, but I don't need to. It's proper. We're done. Number 8, the degree on the top of this is a 3. Degree on the bottom is a 1. So this one's improper. So I'm going to use my synthetic division. X minus 1, change the sign to make it a 1. I have 2, negative 7, 0, 6. I have to put a 0 in because there's really a 0x. in there. Bring down the 2. 1 times 2 is 2. Negative 7 times or plus 2 is negative 5. 1 times negative 5 is negative 5. 0 plus negative 5 is negative 5. 1 times negative 5 is negative 5. 6 plus negative 5 is 1. So my answer, I originally had degree 3. So I'm going to have 2x squared minus 5x minus 5. And then this last number right there is your remainder, plus 1 over x minus 1. Number 9, the degree on the top of this is 1. Degree on bottom is 3. So top is smaller than bottom, so this one right here is going to be proper.